Let's take a look inside the cell. This may surprise you. We've learned a lot about how diabetes is acting inside the cells, and it appears that the defect, the problem, in type 2 diabetes, what we used to call adult onset diabetes, the problem seems to be inside the muscle cells. Now this may be a little bit surprising, but let me show you what I mean. You already know that your pancreas makes insulin to try to escort glucose inside the cells. Insulin acts like a key. It goes to the cell surface, and like a key going in a lock, it opens up little channels that allow glucose to enter the cell. Well, something is wrong. It's as if somehow gum has gotten into that lock. The key is there, the insulin is there, but it's having trouble opening up the lock. The problem may be tiny bits of fat inside the cells. Take a look at this diagram. Fat inside the cells is interfering with insulin's action. The insulin is there. You can see it on the left side of the screen. It's arriving at the insulin receptors, and that is supposed to trigger some changes inside the cell that we call intracellular signaling. It's like the mechanism inside a lock. It's turning the mechanism and then opening the doors to allow glucose to enter. But look, what's that at the bottom there? We see fat accumulating in this cell. That's called intramyocellular lipid. That's fat building up in the cell. It's like gum in a lock. It's interfering with the cell's ability to work. Now, mitochondria are tiny little organelles inside the cell. They're like burners that are supposed to burn up that fat. Somehow, they're not doing their job. So, just to understand this diagram, insulin is arriving at the cell. It's supposed to be a key in the lock, opening up the channels for glucose, but it's not working well because, like gum in a lock, this buildup of fat is interfering with that signaling process. Why is all that fat there? Because the mitochondria aren't burning it up. Okay, let's go a step further. This is the technical term that we're going to use for that fat in the cell. Intramyocellular lipid. It sounds like a mouthful, but it makes sense. Intra means inside. Myo means muscle. Cellular means cellular. Lipid means fat. So intramyocellular lipid means fat inside the muscle cell. Let me take you to a study done at Yale University. This was done in 2004. This was a study of young people. They were all young and thin. They all had a low A1C value. What that simply means is they didn't have diabetes. However, in testing, the testing was a glucose tolerance test. You may have had this thankless test where you drink a sugary syrup. They could see that some of them were already a little bit insulin resistant. So they took the insulin resistant individuals, compared them to those who were insulin sensitive or normal. Now, their age was about the same. Their body weight was about the same. These were thin young people. Their A1Cs were all totally normal. But those who had insulin resistance had 80% more of this fat inside their cells. They had 80% more of this intramyocellular lipid. And what that means is that if you fast forward a few decades, they end up with diabetes or at a much higher risk for it. Let's go to a new study. This was done in Baton Rouge, Louisiana at Pennington Biomedical Research Center. They had 10 male volunteers. Everybody's young, average age about 23, the average weight about 174. And what they did here, don't try this at home, they gave everybody a high-fat diet. About 50% of the energy in the diet was fat. They gave it to them for 3 days, and here's what they found. Not only did the high-fat diet pack fat inside their cells, but the genes for keeping the mitochondria going, these genes were partially inactivated. What does that mean? It means as if the body is welcoming this fat. You're eating a high-fat diet and your body says, oh my, that's wonderful. Let me keep some of that fat in case I need it for lean times ahead. Keep in mind, our bodies did not take form right now or in recent years. The design of our bodies took shape many, many years ago when there was such a thing as famine and starvation. And so at those points, your body liked to store fat in case you needed it. So what I'm suggesting is this. A lot of us are eating high-fat diets every day. Your body stores that fat and tries to store that fat, and that fat seems to trigger something inside the body to actually keep the fat in the cells. So we need to turn it around and have it go the other way. Let me take you to another experiment. This was done at Catholic University in Rome, and they did something that I hope you don't have to do. There were 8 volunteers who had what we would call gastric bypass surgery, a biliopancreatic diversion. And let me show you a diagram of what this looks like. here's the liver at the top of the screen, and then you see the stomach that's been segmented there, and the top part of the intestinal tract has been unhooked, so that's the part that absorbs all the fat. The lower part of the intestine comes up and joins the stomach. The net result is you can't absorb body fat. People lose dramatic amounts of weight with this kind of procedure, of course, and they just can't absorb fat. Well, if you're not absorbing fat from the foods you eat, what happens to the fat inside the cells? Well, here's what we found. Not we, the researchers found this. The amount of intramyocellular lipid dropped 87%. Now, that's huge. What that means is, okay, if I can't absorb the fat from the foods that I'm eating, then I can't keep the fat inside the cells of my body. So let's say I do this not with surgery, but I do it with diet. In Rome, they did a low-calorie diet, fairly typical 1,200 calorie diet. Didn't work very well. It did reduce intramyocellular lipid, but only about 9%. So the next key is to perfect this diet and bring in exercise to make the diet really work. Okay, researchers in London at the Imperial College School of Medicine looked at people following a vegan diet. Now, they ought to be doing better than other people, shouldn't they? Because they're not getting any animal fat at all. So they took 24 vegans, and they had a matched control group. When I say matched, I mean their age was about the same. Their weight was about the same. Their body mass index was about the same. But that's where it ended. The vegans had a lower cholesterol. That won't surprise you. But when they measured the amount of intramyocellular lipid, again, what's that? That's the fat in the muscle cell, in the soleus muscle. That's a muscle in your lower leg. What they found, it was dramatically lower in the vegans. So what does that tell us? That tells us that if insulin resistance is caused by having too much fat inside the cells, and if taking the fat out of my diet can dry up the cells, then a vegan diet that's also low in fat ought to do more than just compensate for diabetes. It ought to help us repair the fundamental cause of type 2 diabetes. And that cause is an abnormality inside the muscle cell, according to the best research we have. So let's quickly review this diet. We explained this in our last session, but I want to walk you through it again just real quick. A vegan diet for diabetes has some real advantages. It boosts weight loss. It may reduce the fat inside the cells, as we were just discussing. It also improves insulin sensitivity. It cuts cholesterol. It helps control blood pressure. It might protect the kidneys because we're not having the animal fat in it. And there are 3 keys. Key number 1, vegan. No animal products, no meat, no dairy, no eggs. Step 2, it's low in fats and oils. Step 3, low glycemic index. Let's just walk through those real quick. Look at the fat content. The leanest beef, 29% fat as a percentage of its calories. The leanest chicken is not much lower, about 23. Fish vary, some are lower, some are higher. But look at broccoli, 8% fat. Look at beans, 4% fat. Rice, 1 to 5. A sweet potato or a yam, 1% fat. So these are the really low-fat good foods. Now, step 2, keep the oils low. So fats are fattening. They all have about 9 calories per gram. You compare that to carbohydrate, which has only 4 calories per gram. Now, fats and oils are mixtures. There might be what people think of as good fats in there, but there are also the bad fats, the saturated fat. So keep them all low. Now, there are a few plant foods that are pretty fatty. Fried foods, nuts and seeds, olives, avocados, and some of the high-fat meat and dairy substitutes, like some of the veggie burgers might be fatty. Others are low in fat, so read the labels. Now, it's good to cook without oil, too, and you can do it. If you've got a recipe that says saute your garlic or onions with oil, you can do that with vegetable broth. You can do it with water. You can steam things instead of frying them. And for some recipes, if they call for oil, use it from a spray, not from, don't pour it. The sprays add only a trivial amount of oil. If you're topping a salad, use a non-fat dressing. Use mustard instead of mayo. Use bean spreads. Use hummus instead of margarine. And if you're having a baked recipe, applesauce is actually very good as a replacement for eggs. In a packaged food, you're reading the label. Look for maybe 2 grams of serving, 2 grams of fat per serving, and total 20 to 30 grams of fat per day. That should be your budget. Now, we talked about the glycemic index. It's real simple. It just means that foods that raise your sugar rapidly are foods you want to avoid. So this doesn't take the place of vegan foods. You want foods that are vegan and low fat, but once you've found them, then you can use the glycemic index to refine things a little bit further. Skip sugar. Skip white or wheat breads, white potatoes. Most cold cereals, unfortunately, have a high glycemic index, and pineapple and watermelon are about the only fruits that are commonly eaten that tend to have a high GI. So those are the ones you want to step away from or minimize. And the foods that you want to emphasize are the low GI foods: beans, peas, lentils. You can't do better. Rye and pumpernickel bread are better than wheat bread. Sweet potatoes and yams are better than typical white potatoes. Oatmeal, bran cereals are good. Most fruits, most vegetables are perfectly fine. Very simple. Enjoy those healthy foods. Now, for complete nutrition, you want to make sure that you take a multiple vitamin for vitamin B12. And there are other B12 sources like fortified cereals, fortified soy milks, nutritional yeast, but you might not be eating those. So I strongly encourage you or anybody following this kind of diet to take a regular multiple vitamin. The fact is, a low-fat vegan diet provides plenty of protein, plenty of vitamins, plenty of minerals, but take that multiple vitamin. That's good advice for anyone. So there you have it. I hope that you'll put this diet to work, and as you do, I hope that you enjoy the taste that you're eating just as your body is enjoying getting healthier from the inside out. Thank you.